Hello and welcome to this video. My name is David Thorne. In this C programming lesson number 4, I'm going to introduce you to integers. Now in the last video we talked about functions, or I introduced you to function declaration, essentially the add, divide and multiply and so on. And we've already seen the printf function, etc. So let's just have a quick look at what we've got here. We've got a declaration of an add function here. And then we have initialization implementation of add function underneath. I'm not going to get into why this is, but this is just a good practice to do it this way, all right? To declare everything before your main file and then initialize it beneath or elsewhere. But like I said, I'm going to get into that in another video. So within inside of our main function, we now have an integer. These are called variables, all right? And I'm going to go through this right now. So let's just move this out of the way. What this line on line 9 is actually doing is it's saying num1 is equal to 4, right? And num2 is equal to 5, all right? But just by comma separated, the compiler knows that, hey, everything after this is going to be an integer. So we don't have to repeat the data type. And int is standing for integer, and it's the data type of this one variable. This is an identifier, right? And this is the data type. So a variable can change its value. I'm not going to get into that right now, and the equal sign is assigning the value of what's on the right hand side of it to the identifier, the variable there, and it has this data type. Now it's very, very important that you understand that an integer can only be an integer, all right? It cannot be something else. So it can be -4, it can be +4, it can be 0, it can be literally any number you want, as long as it's a whole number, all right? A whole number means it's not a decimal or anything like that, right? It has to be a whole number. And so now what we've got here is num1 is equal to 4, comma, num2 is equal to 5. And we could just do this continuously, and these would all be part of our application. So let's remove these two now, all right, and come back to this. And now what do we have here? Well, we have result. And what we're saying is, hey, execute our add function and pass as the first argument here num1, this value 4. So this is basically saying, hey, add 4, and the second one is add 5. But because we've assigned the value of 4 to the variable of num1, or the variable with the identifier of num1, right? And we've assigned the value of 5 using the assignment operator of equals to the identifier, or the variable with the identifier of num2. And we can now use this within inside of our application. So the add function says, hey, give me two values of data type int, and this is the identifier of the first one and the second one, and so on. And that's all we are doing. We are passing the value into this function, right? And we've seen the print function already, and here we're saying the result of %d placeholder plus %d is %d, so integer here, and then we're doing a new line. Whoops. And here we're doing exactly the same thing. We're saying, hey, use this value, right, that's inside of num1 and pass it to the first argument, the first placeholder, and do the same for num2 and then do the same for result. So if we now run or compile and run this, so using GCC compiler, -o is then saying what's the output file name going to be, and it's main. And now we're passing all of the files that should be used to compile. And there is only one right now, and that's main.c. And then we're ending it with a colon just to say, hey, execute the main file afterwards, all right? And we do this, and you will see the result of 4 plus 5 is 9. So if we change 9, right, 9 here, so we've got 9 plus 5 now, right? So it should be 14. And there we go. So this is basically a calculator now that can add stuff. It's a very useless calculator, but it's taught you something about integers. Now, let's do -9 plus 10, all right? And we run this again. Let's just reset this. And now you can see we get 1. Now, if we do minus 9.0, right, what do you expect to see right now? You can see that it's working perfectly fine, right? Because 9.0 is a whole number, right? It isn't a decimal, but 9.1, what do you reckon is going to happen now? Right, this is an implicit conversion from double to int, meaning that we haven't explicitly said it, but you know this cannot happen. It's only a warning, but the compiler has said it's all right. You've told me it's an int, so I'll just dump off all of this. Now let's see what 9.6 does, right? And now you can see 9.6 plus 10. Right, so it's still 9, right? So it hasn't done anything. All it's done is just dumped off all of the decimal places. But this is not good practice, all right? This is not good practice. You shouldn't do this, all right? And we're going to get into how you solve this or what a double is in the future. But you probably got a good understanding right now of what it could be, all right? But we're going to do it in the future. Okay, so in this video, we've now seen how to declare functions. We've now seen how to declare integers. Now, we are well within our right also to declare and initialize an integer like this too. So num1, and then we do num2. And then what we can do down here is we can now say num1 is equal to 10. Num2 is equal to num1 plus 1. All right, so we can also do this, and we can remove this. Now we have the declaration of num1, declaration of num2. These are not initialized, and now we are initializing num1 with the value of 10, and now we are initializing num2 with the value of num1 plus the number 1. All right, and we've commented this out. We're going to get to it later. This is going to be completely ignored now because of these two forward slashes, but it's as if that code did not exist. All right, but we're going to leave it there. Now let's run or compile and run this again. Now we see the result of 10 plus 11 is 21. Well, that's correct. We've got num1 and we've got 10 plus 1 is 11. So the number of 10 plus 11 is 21. So we can, as you can see now, that you can assign or on initialization the value of a already initialized variable to. All right, and if we now come down here and after this we now say num1 is 15 and do a semicolon, right, and we run this once again, you can see that we can overwrite the value of number 1. So the result of 15 plus 11. So num2 has been assigned through the assignment operator the value of num1 plus 1, which was 11, because the value of num1 was 10 at this stage. And at this line, at line number 14, num1 has the value of 10. But what we're doing is we are reassigning num1 with now the value of 15. So when it comes down to the add function here, we are actually using the value of 15 rather than the value of 10 because it's been reassigned, okay? And then when it comes down here, it still has that value, okay? And if we came down here again and we then said num1 is now 13, and we run this again, we saw that it was 15 plus 11 was 26. So let's run this again, and now you can see 13 plus 11 is 26. So we have basically hacked our program to change the value in a part of the memory, all right? And variables are stored in the memory. Now they are stored in different parts of the memory, but they are stored in the memory. So let's just remove all this, and let's bring it back to how it was and run it again. But this here is the most optimum code that you could write. I mean, okay, you could actually put 9 in here and 10 in here because these are completely useless, and the compiler would do that as well. It'd see these are never used and it would replace it, and even result it would see that it's never been used, so it would actually place the result in here. So these two lines of code during compilation would be completely removed anyway because they're useless, because This value of result never changes. This value of num never changes. Num2 never changes. And this is completely irrelevant. So the result would know I'm calling add of this. So it would basically place the result in there. The compilers are super clever. Anyway, there we go. That said, this is now an introduction to integers, but in this video I've also shown you what an assignment operator is, how to reassign values of integers, how to call functions with variables. I've also explained what identifiers are and variables are. So remember, the variable of num1 has the data type of integer, or short reserved keyword int, and it has the identifier. So the variable has the identifier num1, which then has the value of 9, right? And it's mutable. It's mutable. It can be changed. So it's not read-only. It's not a constant, but we'll get to that later. Okay, and we also saw once again printf, how it works, and the different placeholders that you can use. All right, and we also saw that you can declare and initialize or implement a function afterwards. So as long as the application knows about this function, it says this is what happens here is the main says, okay, it's a promise. This function will be implemented somewhere else, but all I can tell you right now is this is what it's going to look like. All right, and the main function says not a problem. I come here, I know what add is, and I'll look for the implementation afterwards. And the compiler says, no worries. Once I've gone through all of the code and done everything, I'll then put everything in the right place. All right, but that's a bit too deep right now. Anyway, I hope you've learned something from this one video. Thank you very much for watching, and I'll see you in the next video.